This is Knowledge Engineering with Semantic Web Technologies, lecture number 6, Knowledge Engineering. And this is the very last part of the very last extra section of this lecture. And here we want to talk about semantic recommender systems and one possibility to use them, to apply them and to achieve them based on linked data. Okay, so let's try to recollect what we already know about recommendations. You know, we have talked about semantic search and we have learned that exploratory search is an extension of the usual traditional search or also the semantic search in the way that it also enables somehow new search results which are not directly found but which are close by. And sometimes you are looking there for similarities or relationships of your results. And as you might know, we had the example of the library, and the traditional librarian in the library usually was somebody who was able to give you a good recommendation for the next book to read based on what you have already read. So what we want to try to achieve with a recommender system is something similar, and which is closely connected also to data exploration and also to exploratory search. So we have to cover the realm from exploration to recommendation. So let's try to remember. Exploratory search, what was it? It represents all activities carried out by a searcher who are either, first, unfamiliar with the domain of their goal, which means they need to learn about the topic in order to understand how to achieve their search goal. Or they are unsure about the ways to achieve their search goals, either the technology or also the process. Or they are even unsure about their goals in the first place, which could also be, but what they want to do then is to browse the available data. And in some way that they are not confused, so they want to browse it in certain predefined directions. And of course, they want to influence according to their preference in which way they explore the data. And there it often comes then to recommendation. So we are talking now about recommender systems, and usually recommender systems are defined that they seek to predict the preferences of their users, and they try to predict the preference that the user would give to a specific item, for example, to a search result. And therefore, a recommender search system connected to an exploratory search would recommend search results according to the preference of the user. Okay, so these are recommender systems. Usually what you do is you define or you distinguish two different types of recommender systems. The first one are so-called recommender systems which are based on collaborative filtering. What does that mean? So this is the way how recommender systems work, for example, for online shops. So usually what happens there is that collaborative filtering approaches construct a model from the user's past behavior. So, for example, from items which have been previously purchased or which have been selected, and some ratings that have been given to those items. So whether it was good or bad, whether you like it or you don't like it. So based on exactly these ratings, based on these purchases, a collaborative filtering model would decide what to suggest next as a recommendation. And it's collaborative, which means it does not only take into account your personal past, but it also looks to users who made similar decisions like you, to users who are similar to you. So therefore, they might find out what other people have also purchased. When you purchase a specific item, you get a new recommendation, which is of course based somehow on your preferences and preferences of users who behave similar like you do. So this would be collaborative filtering. The basic drawback of that approach is, of course, you need user data. You need log data. Without log data, you have a so-called cold start problem, which means, you don't know what to recommend. And this is some place where the so-called content-based filtering comes into play. What is content-based filtering? So there, usually you utilize a series of discrete characteristics of an item which should be recommended in order to recommend additional items with similar properties. So here you go over content-based similarity. You always suggest something which is similar. You know that this, for example, if it comes to online shops, not necessarily is the best strategy. When you have bought a car, usually you do not want in your next purchase again buy a car. So, you know, sometimes this works, sometimes it doesn't. So content-based filtering based usually I say, on similarity. Now let's connect all these things with linked data. So we are looking at linked data-based recommendations. So what is linked data-based recommendation? First of all, it's a special variant of content-based filtering. So of course you can take into account all the data that you find in linked open data. Like for example, you can take into account information that you get over DBpedia about items or about content related to these items. And of course, they are based, or these recommendations are based on linked data resources, which could be either you take into account terminological knowledge, which means you are looking on the ontology, so what kind of a class, for example, an entity belongs to, and how is this class related to other classes and stuff like that. So this would be terminological data. But you can also look at assertional data, so you really try to compare property values of specific entities to property values of other entities. So these two kind of data can be taken into consideration to derive a recommendation. Okay, and then, and this is the most obvious, let's say, difference, you cannot only make recommendations based on similarities, you also have relationships. So you have relations among data. If something is closely related with something else, it does not have to be necessarily similar, but there is a relationship. And exactly, you can also emphasize on this relationship and only recommend close by things, but which in the end do not have to be too similar. So based on these linked data-based recommendation methods, you have much more possibilities than with traditional similarity-based recommendations. So this is an interesting opportunity that we could use. And we want to try it out, of course, with an example. And our example will be movie recommendations. You know, movie recommendations are rather popular, so most of these video of demand platforms, they have the problem that you have watched a video and then of course you want to watch another video, but you have no idea what to look at, and therefore they are presenting recommendations to you. And we, of course, we want to do movie recommendations now based on linked open data. So let's take this case into account. Maybe somebody of you recognize exactly this really iconic keyframe from a rather early movie. Actually, it's from a 1902 movie. It's called A Trip to the Moon from Georges Méliès. And this, of course, is a story which is related somehow to Jules Verne or H.G. Wells, who wrote a story about somebody flying to the moon and being the first then on the moon. And this is a rather prominent silent movie. And it's rather old, so it's more than 100 years old. And the interesting thing, it's freely available on the web, so you can watch it on the web for free. The point now is, so consider you have watched this movie. Now make a suggestion. What should I watch next? But of course, the suggestion should not be too boring. So let's consider that. Okay, first we have to find out, A Trip to the Moon really exists in DBpedia, which is nice. So there might be lots of interesting opportunities and interesting data to look at. We can have a look at it, so let's try that. I will follow that link, and here you see we will go here exactly to the DBpedia page. And what you see here, so it's lots of data we can, for example, work with. So you have the director and producer, which was Georges Méliès, and you have a runtime given here. Also, you have some people who occurred in the movie, so there is a starring property. And what is also interesting, there is a writer, there is a budget, so problem is you don't have, let's say, a currency for that budget, so not necessarily you can compare other things with it. You have a country where it comes from France. That's interesting. What else? You have a language. Of course, it's a silent movie, so no language restriction on that. You have a runtime, probably seconds. I don't know exactly. Then what else do you have? Yeah, this is interesting because here the subject gives you a category. So these term subjects are the categories to which the according Wikipedia page has been gathered or collected. So this belongs to Wikipedia categories. For example, it belongs to the category black and white films, which gives again some hint to the content of that movie. It also, so you see here more specific categories like, for example, French science fiction films or 1902 films or films produced by Georges Méliès and stuff like that. So this is really, really interesting information. And it's the same here for RDF type. So in RDF type, you see some general types that determine that this is a film or this is some kind of artwork. But here, this is also interesting, you see the Yago classes. Yago is another interesting ontology which has been connected to DBpedia. And these are also classes which are rather refined, rather sophisticated. So for example, you have here films based on the works of H.G. Wells, so which is rather nice to know. So also you have a category where all pre-1950 science fiction films have been collected together. So this is interesting information that could be taken into account to generate again then a recommendation. So you see there's pretty much stuff that we can use. So let's go back to our presentation. Okay, so this was the Wikipedia page. So what can we do? Of course, for our item under consideration, we have to gather as much information as possible to do a perfect characterization of that. You know, an item, usually in semantic resource, is characterized by the number of all its properties and property values. And of course, we could take into account everything we know about DBpedia, but we could also go to alternative knowledge bases. Like, for example, we could use Freebase, we could use, especially for movies, we could use IMDb, which has lots of movie information, or we can go to a rating platform like Rotten Tomatoes. There I can get some measurement for the quality, for example, of a movie, how users liked that movie. So all these data can be taken into account when generating a recommendation. For our example, we want to focus on the DBpedia data. And what we find out here, for example, is that Georges Méliès is the writer, the director, the producer of that film. We know that, of course, the film or the movie belongs to a category which is called film. And also we have all these DC term subject categories from Wikipedia that I have shown you in the DBpedia page. And a recommendation could be made in the following way, that, for example, we look at the most likely connected of these categories, where also Georges Méliès, who is one of the properties which is connected most exactly with our starting entity, and then we end up in this first category because both Georges Méliès and also this movie is connected to exactly that category. And then we are looking for films in that category, and then we are looking for films which have the most properties in common. And you might end up, for example, with a film like that with Hugo, which is a film, I guess, by Steven Spielberg, and the story is, of course, about Georges Méliès. And this is a rather nice movie, which is, of course, related to your original movie, and maybe you are interested in that. But this could be, as you see here, a rather sophisticated process. We want to do something easier, something simpler. Okay. What we could do simply is we could search for similar movies in the sense that we say, okay, just look for movies that share the most of these categories. So then we say we will find something pretty similar, which could be a rather good recommendation. So let's have a look at the Sparkle query I have prepared for that. What we do here, we have to do a little bit aggregation here, therefore it's more complicated. Just let's first have a look at the query patterns in here. So first we say, okay, we are looking to our original resource, which is a trip to the moon, and we want to find out which is the subject of that, so which is the category. O here is the category. And then we are looking for a movie which has the same category, which is also DCT subject O. And of course, we want to exclude the very same movie we are looking at right now, because this would be, of course, the entity with the most sharing categories. So therefore, we want to exclude it here in the filter condition. And then what we do is we group the results simply by movies. So what we get here for each of these categories, we would get a result line, and we want to aggregate this by movie. And then we order it, or we order our list that the most shared categories then stand on top. And then let's have a look at the result list. In the result list, first we start here, of course, with a counting of the movie, and also then with a sample from which movie was recommended. So for one of these categories, it's always the same movie. So here, movie is here the same, and then we have several categories which are counted here. And therefore, we can take simply a sample of that. Okay, so let's carry this out, and you will end up, so you can do this simply by clicking here on the link to the Sparkle query. I won't do it here because this slows down the lecture and you have to invest much more time. So this would be a prepared result that you achieve if you directly carry out that Sparkle query. And then you see you will get some interesting results. So here are 2 films that share overall 6 categories with our original movie, The Trip to the Moon. And this would be The Impossible Voyage and Gulliver's Travels Among the Lilliputians and the Giants. Yeah, which are also 2 kind of fantasy or science fiction movies, and possibly these are some good recommendations. And then you see here in decreasing order other recommendations which share 5, 4, and even less categories then. So this is quite interesting. But of course we want probably to know why these movies have been recommended. And what I did here in the next Sparkle query, that you also can access here via the link given below here, is I have given also as a result the categories which contain or which belong to the movie and which the movie in the result shares with our trip to the moon. So they are here aggregated, in another column. And you see here, for example, this Gulliver's Travels movie. This shares several categories, like, for example, it's also a French silent short movie. It's a 1902 film. It's a film also directed by Georges Méliès. It's a French film. It's a black and white film. And it belongs, this is also interesting, to a category which says it's an article containing a video clip. Yeah, this of course might not be an appropriate class for a movie recommendation. And you see also here the Impossible Voyage, in which classes it is there. You see it also here, for example, the Cinderella film, which has 5 classes, and so on and so on. So you see, or you can justify your selection simply by stating, yeah, I recommend this movie simply because it also belongs into the following categories, which would be a nice result. Okay, yeah, I could also, instead of looking to the categories, I could also take into account all the information that, for example, here comes from the RDF type information. And what I did here is I have the very same query, but I do not look for DC terms subject, I look for RDF type. And now I look for all the results that share the most types. And if you try to link to that Sparkle query and carry out that Sparkle query, probably what will happen is that your Sparkle query will not come to an end. So I have prepared something like that here. So this is here, let's say, a filtered Sparkle query because the original query won't work. Why is it that it won't work? The question why it does not work is there, of course, are types, which means classes, which have millions of members. If you remember, for example, there was a class owl thing. Each single entity is in the class out thing. So what we have to do in our Sparkle aggregation is we have to really make a comparison of each single entity. Or if you have classes like movie, I guess there are several 100,000 movies in Wikipedia. Also, you have to take into account all. And of course, this might be difficult. So therefore, I have restricted this query again then to the Yago classes, for example. And then you see, because the Yago information is a little bit more complete than the DC terms type systems, nevertheless, it's almost the same. You see here another kind of recommendations of things that share here, for example, 8 or 7 classes. And you see here, of course, other kind of movies that have been recommended. So in the top class here with 8 common things, you have here Le Voyage de Gulliver. I think this is the very same, or might be the very famous film, very same film, only here with a French title. So I guess so, I'm not quite sure about that. And you see, yeah, similar recommendations, a little bit different, but nevertheless maybe interesting for you. And of course, you can now play around with all this. And again, if you here look, for example, at the classes that are shared, you will see here all the classes that are shared, but there are also rather, let's say, common classes like the general movie class, or here a general object class, which share nevertheless all of the available entities. And of course, therefore, these queries take a long time because the aggregations and comparisons really consume most time of this Sparkle query. I have made a further refinement and did the following thing. So what I did next is I said, okay, there are type informations, there are category informations, but there are also other informations. So for example, the movies might share the same director, they might share actors, they might share the location where they have been filmed and all the stuff. So why not simply take into account all the properties and simply search a movie that shares most of the available properties? But of course, if you do that, if you're looking for an entity which shares the most properties, I did this right here, so the query has been slightly adapted. So now I'm looking here also for a variable for the properties I'm looking at. But of course, I'm not interested in all the entities that share the most properties. I have, of course, restricted which entities have been or have to be selected. So the entities to be selected here, the movies, should really be movies. So they should belong to the category DBO film. And then I have here again, they share the same property and they share the same object or object value. And then again, it's grouped by movie. And again, I count here the shared properties. And you see here, that's quite interesting. So we have now another list generated by that query. And now we have 17 really co-occurring property values. So, and here the best recommendation is a completely different movie. It's The Man with a Rubber Hat. I have no idea what it is, so you should look it up. And that's also interesting. Then you have lots of recommendations of things which share 16 common properties, like, for example, the Flash Gordon serial. I guess this is the serial from the 1930s, or the creature from the Black Lagoon, or also here in the end, Mr. Moto's Gamble. So this is more or less a mystery movie. So, but it's interesting, the recommendations you get. So simply try to play around with it. You can use this for content-based recommendation. For example, if you're using a video on demand platform and looking for a new movie to look at, simply try out one of these Sparkle queries. Maybe you will get a nice and interesting answer for your query. Of course, there are some pitfalls to be avoided. We all know that for movie recommendation, if you always get a recommendation of something similar, then it soon starts to be boring. So 2 similar recommendations might be boring, and you should avoid that. So, which means you should enhance somehow something which is called serendipity. What does that mean? You should find something unexpected, what you did not think of it previously, but nevertheless it's important or useful for you. So this is something interesting, and therefore you have to relax somehow this similarity issue and should go more for the relatedness issue. So this is something you could also play around with. And I can show you, for example, what might happen in our original example if we here do not go to the most similar category, which was the category of Georges Méliès. If you go, for example, to another category like the moon in film and simply look to the most popular film in the moon in film, what you might find there is, for example, Iron Sky. And this, of course, is a complete different recommendation. And possibly it's not boring, but of course you see the clear connection between the two movies. It's of course about the moon in film, and therefore you might be interested in it. So this would be then something which you probably did not think of when you originally asked for a recommendation. And then, if you like it, it would be relevant for you, and therefore it would be a serendipitous discovery for you. So this would be a nice effect. Okay, so let's sum up again. Linked data-based recommendation makes use of linked data resources to generate content-based recommendations. And the interesting thing here is the content-based recommendations can be based as well on similarity as well as on relatedness of the resources, which opens up a new and brighter scope of your recommendations, and possibly also better recommendations than with traditional recommender systems. Of course, you should avoid to recommend results that are too similar to your original start, and therefore you should somehow enable serendipitous discovery. And with this, we want to end our lecture on knowledge engineering with semantic web technologies. I hope you have enjoyed the lecture and you have learned a lot. We, of course, the team and I, we have also enjoyed preparing this lecture for you. And of course, we are looking to the future, and stay tuned. Maybe we also want to offer more lectures on similar topics. Okay, thank you and bye-bye.